Welcome. The title of today's notes worksheet is Solving Quadratic Equations, Day 2. Just a reminder, for this one you will need the quadratic formula program from me, so please, before kind of going into this, just make sure you do get that. Just takes a second for us to link up calculators, and I can upload it to yours. So anyway, we'll go ahead and do a little of the completing the square again, review that piece, and then get on to method number 4, which is, of course, the quadratic formula. So let's kind of review and expand on what we did yesterday with completing the square. What I did is on your paper just kind of laid out some strategies. Most of these we saw yesterday, but at least you have it in writing there just in case you're not sure of something. Kind of go back and take a look. The only new piece, and I guess that's what we'll write, this is sort of the additional step. And you don't have to do this every time, by the way, as we'll see. But that is the additional step from yesterday. Everything else should pretty much be the same. So again, I'm going to let you take a look at that and read that over. My job, I guess, would be to just do a couple of the harder ones here, and let's see if we can walk through some of the mathematics. But at least you have that in writing just in case. Okay, so let's go for it. Example 1, solve each quadratic equation. And notice it doesn't say solve by completing the square. So I would run through the methods a little bit and just kind of talk yourself through is, can I do this, can I do that, and so forth. So when I see this, x squared minus 5x plus 1, the first thing I would ask myself is, can it factor? Because that's nice, it's quick and efficient. Unfortunately, I can't think of two numbers that multiply to 1 and combine to negative 5. So it doesn't factor. So I would look to undo the square. And unfortunately, as we saw, this is not a candidate for undoing the square because of that minus 5x. So no square rooting here. So what that leaves us at this stage is doing completing the square. And the way it plays out, x squared is great, minus 5x. I'm going to complete the square on those two terms. The 1 moves over. Notice it becomes negative when it moves over. And I'm going to put a blank on this end as well. So here is the key. I need you to be able to pull this piece off. What goes in the blank in order to complete the square? So take negative 5, divide it by 2, and I know it doesn't go in evenly, so just leave it as negative 5 over 2, and then square it. If you did it correctly, negative 5 over 2 squared should be plus 25 fourths, so positive 25 fourths. And again, if you're not sure on that, basically just take negative 5, divide by 2, and square it. Negative 5 squared is 25, 2 squared is 4. Okay, I'm going to erase that so it doesn't get in our way in terms of solving the equation. So now we can go back to solving. All right, beautiful. Left side, right side, everybody. Left side. The whole reason for completing the square is because it factors into what is called the square of a binomial. And so what we would think about in terms of factoring this, x times x is the x squared. What times itself would be 25 fourths? Well, obviously 5 times 5 is 25, and 2 times 2 is 4, so 5 over 2. And then if it has to combine to a minus 5x, then this has to be minus minus. And so as a result, x minus 5 halves times x minus 5 halves. Okay, so that is the left side. Now the right side, going to have to get comfortable with fractions. But I think we can work this out here. If I do negative 1 and then 25 over 4, well, we just sort of talked about a whole lot of rational expressions where, basically I need to combine fractions, getting a common denominator. So I'm hoping you're okay with me just doing this verbally. Negative 1 is really negative 4 over 4. So negative 4 over 4 plus 25 over 4, I'm getting as 21 over 4. All right, square root time. So it is in a perfect position now because I can solve for this variable here by doing undoing the square and adding the 5 halves. So let's do it. The left-hand side is just x minus 5 halves. Don't forget, when you undo the square, please include the plus or minus. And what we would want to do here in terms of this square root is just take it piece by piece. Square root of 21 I really can't do much with, but the square root of 4, of course, is just 2. And so I would kind of leave it like that right there. And then as you can see, we're going to add 5/2 to this side over here. And you can do this a couple different ways. I'm going to just write it like this momentarily. So this moves over and becomes positive. And if you kept that as an answer, that's fine. It's not that big of a deal. I like expressing it because it seems like we have the plus or minus, so we can combine two fractions that have the same denominator. I like this expression right here personally. So 5 plus or minus root 21 all over 2. This is just a more compact version, of course, of this piece right up here. I'm going to go ahead and box that one up and take a look at that and see if that makes pretty decent sense. You can see, obviously, it's the same process as yesterday. It's just now the numbers are harder because there are fractions involved. Okay. So let's get one more practice on it, and that would be letter B, and this is probably as hard as it's going to get for us in terms of completing the square. I will tell you up front, this does not factor, so unfortunately that is out. But we go back basically to completing the square, and notice the major difference here is that we have a number in front of the x squared. So I'm going to go back a screen for just a second, and this is the one additional step to yesterday's lesson. In order to sort of get this ready to go, we want to complete the square on the first two terms, and we want just a single x squared. It just makes everything so much easier. So what we're going to do to remedy the situation, divide both sides of the equation by a if the coefficient is not 1. So that's that first piece right there. And because it's an equation, we can do this, because I'm going to divide the whole left side of the equation by 3 and the right side of the equation by 3. Now I know it's not ideal because, of course, that works, but now I've created fractions when there were none, but I'm afraid that's how we're going to play it out. So we divide everything by 3, and I get that piece right here. Now it's ready, not pleasant, but it's ready to roll. So I would ask us to kind of pull a couple things off here. So x squared minus 2/3 x. Now it's ready, guys. Complete the square from the first two terms. And again, no number in front of the x squared. That's good. Bring the 4/3 over. Put a blank on the back because we have to keep it balanced. Here's where I would ask you to just pause the video for a second. Can you pull it off? Can you take this and divide by 2 and then square it and get me a nice simplified perfect square in there? Let's see if you can get that to work. All right, I'll tell you what I got when I did this one. I ended up getting, when all is said and done, a plus 1/9 and a plus 1/9. So let's see that in action first and foremost. So I have the negative 2/3, and I would divide that by 2. Because this is a fraction, I'm going to treat it in a slightly different manner. Dividing by 2, I hope everyone is in agreement, is really the same as multiplying by 1/2, right? So I get really negative 2/3, and then dividing by 2, so multiplying that by 1/2. These 2's are going to cancel when I do that. And as a result, I get negative 1/3. That is the b over 2. And so I square that, and negative 1 squared is 1, 3 squared is 9, and there's my piece. So that's how I kind of pulled that off there. Hard one for sure. But it does work now because I formed what is called a perfect square trinomial, and I should be able to factor it as exactly what you see on the board here, and then we'll simplify the right-hand side. So let's see if we can do it. Again, maybe you're working half a step ahead of me. That would be really the ideal for something like this. X times x is x squared. What times itself is 1/9? Well, it's got to be 1/3 times 1/3. So we've got that. And again, if I was to FOIL this back out, it has to combine, the outside and inside would have to combine to a negative, so it has to be minus minus. So x minus 1/3 times x minus 1/3. Okay, good. Now this side over here, just good fraction work. We can do 4/3 plus 1/9. I'm getting a nice LCD of 9. So how about something like this, everybody? 12/9 plus 1/9. And 12/9 plus 1/9 gives me that. All right, again, not easy by any stretch of the imagination, but definitely within your capabilities. Factoring, fractions, all good. Now it's in the form we want. So we undo the square, we undo the minus 1/3. And so let's undo that square first. Plus or minus on that, everybody. Square root of 13 I can't touch, but square root of 9 is just 3. This will go over, everybody, at this stage, and you can kind of see common denominator of 3. Just be careful. I've seen students do such great work up to this point. And then when you add 1/3, just remember when it goes over here, you're adding 1/3, so it's a positive 1 plus or minus root 13 over 3. I've seen a lot of students throw in a negative there accidentally, but no, of course, you want to add 1/3 to both sides. And so that is your answer. Nice solution set. 1 plus root 13 over 3 and 1 minus root 13 over 3. All right, again, that's pretty much as hard as it's going to get with completing the square. I hope that worked for you. Please let me know if you have questions on that. On to the last, method number 4. You have definitely seen this before, so the way I figured it, we would kind of do maybe one by hand if we needed to, and then kind of do a little quick derivation on it, see where it comes from, and then let's use the calculator to do most of the work on these. So it'd be great if you can remember the quadratic formula here. So before I put it in, and this is the nice thing is, it's basically given any numbers for A, B, and C, the variable is equal to something. And if you remember correctly, in terms of A, B, and C, it was the opposite of B plus or minus, big square root here, and under the square root, you get what is called the discriminant, that B squared minus 4AC, and all of that is over 2A. We'll probably revisit this in the future when we do some quadratic functions. But yeah, basically there it is. That's given A, B, and C. They'll get you the values of the variable every time. Again, we'll derive that on the backside, sort of see where that comes from, now that we have the skills to kind of pull that off. It does say solve example 1B using the quadratic formula. Guys, this will probably be the only time I ask us to do it, but it should be at least once. You know, kind of seeing it in action, that it does work. So I'm going to solve the exact same equation. I think completing the square is actually easier, to be honest, and better. But some students fall back on the quadratic formula by hand. I'm going to try to discourage you from it. I like completing the square better. But once we'll go through it. So here's sort of the idea. I hope everyone's in agreement that A is 3, B is -2, and C is -4. And so what that would basically mean is opposite of B. So let me put a big X equals, just getting me going here. So X equals opposite of B plus or minus, big square root right here, and I have B squared, so -2 squared, minus 4 times 3 times -4. And all of that, of course, is over 2 times 3. So again, just one time through using the A, B, and C, and let's see if we do get the identical answers from when we completed the square on it. Let's see, I'm looking at that square root initially just from my end, and I get a 4 and then minus, it looks like 4 minus -48. And if you have a calculator handy, you can kind of type that in, -2 squared minus 4 times 3 times -4. I'm getting a 4 minus a -48 just from my vantage point. Long story short, I'm getting a 52 under that root. And then over 6. Okay, great. Let's keep going here. That actually is our answer. I think this can be simplified quite a bit further. And again, just good math, that's all. That's what all this manipulation is. If you remember kind of simplifying roots, there is a perfect square that goes into 52. It happens to be 4. So I'm seeing this as 2 plus or minus, I believe this is going to be a 2 root 13 then, because 4 times 13 is 52. So if you kind of have that piece, remember simplifying roots, and then over 6. Nice. Keep going. I'm going to bring this on up here. Just looking at it, I'm liking the simplifying here. I'm looking at the top, and we do have to be careful. Don't want to cancel out at this stage, because remember, it's separated by a plus. That doesn't work. But I do see on top, I almost want to sort of factor out a 2 on that. So I'm getting this piece. So factor out a 2. And now, everybody, can I reduce the 2 over 6? Yeah. So 2 over 6 is 1 over 3. And you knew it was coming. It's the same equation, obviously. So same solution set. Oops. And let's change that real quick. I was thinking one thing, and I wrote another. There we go. Over 3. Nice. So one time through, again, I like that completing the square, especially because we're going to use it quite a bit this semester. So really get confident and comfortable with completing the square. But, it's nice to see that the quadratic formula certainly does work. Get the exact same solution set as when we solved it before. All right. Well, I figured we would go ahead and do just the quick derivation of it. Again, I wrote out some steps on your notes worksheet here to kind of help us along, but we totally have the skills to kind of see this in action. It's one thing for me as a teacher to just show you, hey, here's the quadratic formula, and look, it works, and so forth. But, why does it work? And so we're going to prove that momentarily. And then we'll pick up the calculator and get used to that program for just a little bit. So here's the idea. On your paper, if you would, start out with this. And we are going to solve for the variable. A's, B's, and C's, those are essentially constants. Those are our numbers. In terms of A, B, and C, can you solve for the variable here? Well, as it says, what we're going to do is complete the square. In fact, there it is. We're going to do exactly what we did on the front side of this notes worksheet, complete the square. All right, well, let's go for it. Everybody, if I'm going to complete the square, I don't like that A out in front. It bothers me. So let's get rid of it. I have x squared, b over ax, c over a equals 0. Perfectly okay. I divided the left by a. I divided the right by a. Okay. Now, guys, let's get it ready to complete the square. That goes over, blank. Becomes a negative c over a, blank. And here, to me, is pretty much the crux of the entire derivation. Can you figure out what goes in that square this blank right here, which will obviously go in this blank over here? So take this guy right here, divide it by 2, and then square it. Well, when I did this, divided by 2 and square it, I got a b squared over a 4a squared. And I'll write this on the other side and then show you where that came from. B squared over 4a squared. And so really, and I'm going to erase this momentarily, but when I take that b over a and divide by 2, really it's just like tucking a little 2 in the denominator there. Remember, dividing by 2 is the same as multiplying by 1/2. So you just get another 2 in the denominator. Then you square, and there it is, guys. Remove the parentheses. B squared, 4 squared, a squared. Okay, away that goes, lest it distract us. And let's go on to the next piece. So that was good. I like that piece. The second most important piece is this. Can we factor and can we combine? And so remember, x times x is x squared. What times itself, everybody, would give me this? Well, b times b, 2 times 2, a times a. And if it has to combine to a positive in the middle, it's going to be plus. So x plus b over 2a squared. And, you can start to see some of the quadratic formula form. I would obviously ask us to combine two fractions together. We would need a common denominator here, which is 4a squared. Typically, as you all know, you see that b squared out in front. So that one, same denominator, so no need to change the numerator. This one, we changed the denominator by 4a. Hope you all see that. It was a. Now it's 4a squared. So we changed the denominator by 4a. Let's change the numerator by 4a. So you get 4ac. Awesome. Now we're ready. Square root. I get x plus b over 2a. plus or minus. Now just be careful, because of that minus right here, the square and square root do not cancel, as a matter of fact. And we kind of talked about that before, as with that minus. This is all attached as sort of like a single factor. So it can't just sort of do that piece. It's just not algebraically legitimate. But down on the bottom, because it's separated by only division here, this, the square root of 4a squared, is 2a. So that is okay. And good. Hey guys, you can see it. That's coming over. Common denominator of 2a. When it goes over, as you can see, this becomes negative, or its opposite. And we've got it. So you can see all I did, nothing new, as a matter of fact. Wow, that looks like a 9. Hang on. Let's fix that. So this would be a 2 and an a. So yeah, you could see just sort of the whole reason the quadratic formula works is because we solved for the variable by completing the square. And we got what the variable would be equal to in terms of a, b, and c. Nice. All right. Well, let's pick up those calculators and let it do some work for us. So examples 3 and 4 go together. Let's get a little practice on this piece and round it out here. A baseball player hits a foul ball straight up into the air. The ball leaves the bat from 3 feet above the ground at an initial velocity of 120 feet per second. The equation, and everyone, if you don't mind, can you box that up for me? The equation models the height of the ball in feet in terms of time in seconds. So it's a relationship of two variable quantities. We're going to be doing a lot of that this semester. But in this case, I've got height in terms of time. So this is the mathematical way to convert the time values into the height values. Okay, the catcher is set up to catch the ball when it is 6 feet above ground. And after how many seconds will this occur? So I'm hoping you agree in this particular case, the catcher is set up 6 feet above the ground. I'm giving you an h value, and I'm going to need to solve for t. So what we're going to do is put a number in for one of the variables and solve for the other variable. In this case, it's what's called the output. So the height here is the value that's given, and we're going to have to solve for what is called the input, in this case, t. So we have that piece right there. Okay, now this is an equation that we can solve. It's quadratic. It's one variable. We would solve for t. The only dilemma, of course, is it's not in that great default position here because it's set to positive 6. So I'm hoping your first instinct here is to subtract 6 on both sides. And so I do exactly that, negative 16t squared plus 120t, and it would just be minus 3 in this particular case. All right. Now you would solve this quadratic equation, kind of run through our methods. You would say, hey, wait a minute, can I factor this? Nah, it doesn't factor. Can I undo the square? No, I can't undo the square because of that. Can I complete the square? Yeah, I can definitely complete the square, but that doesn't look pleasant at all, does it? That looks above and beyond unpleasant. So we go down to the fourth method there and just go to the quadratic formula, and we've got it on the calculator. And so what we're going to do is figure out that a is negative 16, b is 120, and c is negative 3. Okay, well, I'm going to bring my calculator up here. Let's see. Hang on one sec on that. Okay, I think I have that ready to go here. So let me go ahead and grab that. There we go. And so what you're going to do for me is go to Program, and you should see at this stage quadratic formula or quad form, and hit Enter. And hit Enter again for me, please. And notice it prompts you right away for what is A. And so we're going to type in that negative 16 here. So everyone do that with me if you would. Negative 16. And it says what is B. And I think we got our B is 120. And what is C? Our negative 3. And notice how nice that is. It looks like it spits out a couple answers at us. And so we get our decimal approximations here. And I'm getting a t is about 0.025. Everyone see that? So I'm going to write this. T is about 0.025. And t is also, I think we saw about there, 7.475. Right in there. Excellent. Those would be the two time values that the baseball would reach a height of 6 feet. After this many seconds, and after this many seconds. Now just in terms of the problem here, because it's an interesting problem, it does say the catcher is set up to catch the ball when it is 6 feet above the ground. After how many seconds will this occur? I'm obviously assuming that the catcher is going to catch it on the way down, which would probably be this one right here. So, in terms of solving the equation, both answers do work. I have a feeling this is when the baseball hits 6 feet on the way up. So I'm going to write this. How about this? This is on the way up. And then this one, of course, would represent how many seconds it's going to hit 6 feet on the way down. And that, of course, is when the catcher is going to catch it there. So we would probably take this one right here. Hopefully that helps. Okay, good. Nice and easy. Quadratic formula program does really most of the work for us. Let's go do that last one then. One more here. So it says the quadratic model, and everybody, if you don't mind, can you box up that quadratic model for me? Represents the path of a kicked football. Y represents the height of the football in meters, and X represents the horizontal distance from the kicker in meters. Find the horizontal distances when the football is 5 meters above the ground. And again, in this case, it looks like I am giving you a height, which in this case represents the Y value. And so I don't know what's going on here. Essentially, you don't have to do this if you don't want, but path of the football is going to look something like that. And I'm assuming it'll be, here's your 5 meters. And once on the way up and once on the way down, the ball will reach that height. Okay, well, let's keep it pretty straightforward here, everyone. If I give you the Y, your job is to solve for the X. So once I put a number in for this Y value right here, then it becomes a quadratic equation in one variable that I can solve. I'm not factoring. I'm not undoing the square. I'm not going to complete the square here, everybody. I am going to let the calculator do the quadratic formula. But we do want to set it to 0 first. So let's go ahead and do that. So I get this is my equation. Make sure I have my numbers right there. And how about a -5? If you don't need to write this piece down, if you kind of know that, then no worries whatsoever. But B is the 0.75, and then C, of course, would be -5. All right, looks great. I'm just going to do the quadratic formula program one more time. Let's get those two distances. So when is it going to be 5 meters above the ground? Once on the way up, how far away from the kicker? Once on the way down, how far away from the kicker horizontally? So let's go back and hit program. Quad form, hit enter. Hit enter. And again, it prompts you for that A. Just be careful on this one. But it's -0.0192. B, I'm getting a 0.75. And C, I think we said was -5. All right. I get those two right there. So it looks like X is equal to about 8.529 meters horizontally away from the kicker. That would be right here, give or take. So that, let's see if I can get that a little better, about 8.5 meters, give or take. And then also, I think I saw something about 30.534 meters. And so that would be the horizontal distance from here back to the kicker. All righty, nice. Let's, I'll box those up. Pretty straightforward once you have that quadratic formula program. But please, you are certainly responsible, especially for the completing the square. Make sure you really focus in and practice that piece. You're going to see that a lot this semester. Well, thanks for listening. If you have any questions, please don't hesitate to ask. Otherwise, just kind of work on the quadratics. Make sure you're pretty comfortable with that piece.